If you were asked at this point to find f prime of x, the only thing that you would be able to do is use your limit definition of a derivative. And the reason is, at this point, you only know the power rule, and this is not a power function. This is a rational function. It is the ratio of two functions. So we would proceed with this limit definition of the derivative and find a common denominator, simplify everything, multiply by reciprocals, etc., and we would find our derivative. So here's what the quotient rule says. If you have some function called h of x, which is defined as the ratio of two other functions, f of x divided by g of x, h prime of x, the derivative, will equal this. And now this looks kind of crazy, and it is a little crazy. What this is it's the derivative of h, which will equal the denominator multiplied by the derivative, that's f prime of x, the derivative of the numerator, minus the numerator multiplied by the derivative of the denominator, that's g prime of x. And this whole thing is all divided by g of x squared. And yes, you need to memorize this. This thing is the quotient rule. From now on, every time that you see something like this, you're going to find the derivative of that function by using this thing called the quotient rule. So in other words, whenever you have a fraction, to speak plainly, you're going to do this. So the question is, how do we remember to do this? And there is a poem, if you will, or a song that we're going to learn that will help you to remember this, and here's what it is. The poem says, well, actually, let me identify a few key parts, key ingredients for you first. So here's your key for the song. When we say low, we're talking about the lower part of our initial fraction. It's the denominator. High is the upper part, the numerator, and then d stands for derivative. So we're going to turn this madness into a little song using these words, low, d, and high. Stanza number 1 goes like this. Low, d, high, less high, d, low. Low, d, high, less high, d, low. Say that to yourself 10 times. Literally, hit the pause button and say, low, d, high, less high, d, low. What this means is this. Low, this is the denominator. Take the derivative of the numerator, and that's what's going on right here. This is low, d, high. This is low, the lower part, g of x, derivative of the upper part. Low, low, d, high. Less means subtract. So less, and then you've got high, d, low. This is high, the numerator, and then d stands for the derivative of the lower part, which is g of x, the denominator. Low, d, high, less, low, d, high, less, high, d, low. And then here's stanza 2. Draw the line. Easy enough. That is referring to this massive division symbol. Draw the line. So we have low, d, high, less, high, d, low. Draw the line. And then here's stanza number 3. Down below, denominator squared must go. G of x is our denominator, and we've got to square it. This, my friends, is the quotient rule, and if you learn this little poem, you will never again suffer the wrath of the limit definition of a derivative for a fraction, which is good news. Low, d, high, less high, d, low, draw the line, down below, denominator squared must go. Memorize this, learn this, know this, never forget it. Low, d, high, less high, d, low, draw the line, down below, denominator squared must go. Do it again. Low, d, high, less high, d, low, draw the line, down below, denominator squared must go. Maybe we'll put it to a tune later. So let's go ahead and do this example that I started with. F of x is equal to 2x over x squared plus 4. This thing is represented as a fraction, so we're going to use our quotient rule and find f prime of x. Here's how I want you to think through this. Low, d, high. Let's start with that. Low, d, high. I'm going to take low, which is my denominator. Low, so let me rewrite that. Oh man, I'm having iPad troubles here. Let's see. All right. Low. I'm going to keep things grouped. D high. D high means take the derivative of the numerator. So that is going to be the derivative of 2x, which is 2. That's low D high. Less high D low. High D low is going to be the high part, or the numerator, multiplied by the derivative of the denominator. That's the D low part. So the derivative of the denominator is going to just be 2x, which happens to be the same as the numerator there. Again, I found that out using my power rule. The derivative is going to be 2x to the power of 1 plus 0. Draw the line. Down below, denominator squared must go. So x squared plus 4 is going to all be raised to the power of 2. This is my derivative. I'm done. Technically, I'm not done. I need to simplify, but this is the derivative, and this is the derivative anywhere. For any value of x, I could plug x in for all of my x's and know what the specific value is. Hey, this thing looks deceiving. This is not plus negative. This is just a plus sign. My pen skipped there. So let's simplify this thing by doing some distributing and see if we can make this look a little bit better. 2x squared plus 8 minus 4x squared. This is going to simplify to negative 2x squared plus 8. Oh my goodness. Let's try that again. Plus 8 all over x squared plus 4 squared. Now, we could multiply this binomial out. We could FOIL that out. It's actually not going to help us in any way. So let's see if we can do anything else. It looks like this numerator has a common term there of 2. So if we factor that out, let's see what happens. And it looked promising for a minute. It looked like we might be able to cancel out an x squared plus 4 term, but we can't because of that negative sign. So this is about as good as it's going to get. This is my answer. This is f prime of x using the quotient rule.